So a couple of months back, I did a video on my 12 volt AC power supply that I use for all my Lego projects. It was kind of a rough video. This was before I had my lav mic and a few other little upgrades. So I thought I'd revisit it, and I also did an upgrade to it. So we'll talk about that in a second. Now, this train regulator is powered by the official Lego transformer plugged into the wall. And I've got it running 2 power function servos to switch directions on the monorail tracks. And you can watch this 9 volt incandescent light and watch how it reacts as I move them. It's not that much with one, but 2 together, you can see how much the light dims. So it's getting, the voltage is dropping out a little bit. And I actually had some issues with this when I had one of these that was it was binding a little bit and giving more of a load than it should have been, but it would get stuck in weird positions and do strange things. So I'm gonna do a little better than that. So this is, again, using the official transformer that came with these. So now let's switch over to my power supply. And I've got, this is measuring amps on the AC side, so it's on the input side, and then that's measuring voltage, which is 14 volts unloaded. It will drop as we put more of a load on there, and that's controlling 2. And it just barely dips, and it just works better because these train regulators can actually do a little more than they can with the official transformer. And I've heard so many numbers thrown around, like these can do 1.5 amps, they can only do 1 amp, they can only do, and there just seems to be some disagreement there between everybody, which is common with these types of things, you know, because everybody's kind of, some people are more theoretical and doing all the calculations, and some people are like, well, I've done this in the real world for years and never had an issue. So it's hard to know who to believe. So I'm gonna pop this open in a second here and show the inside. This is the old transformer that was in there, and this came out of here. You can see it's rated at 2000 milliamps, even though it had a 5 amp fuse inside there for whatever reason. And this isn't an AC adapter because it's not adapting. It doesn't have a bridge rectifier. It's literally just a transformer, and then it had a fuse mounted to the board here, which I blew. That's why it's not there anymore. But I just think this would be a good project for people in the GBC community, or people that do trains, or you know, try to set up big layouts. Like some of my projects just around the house, I've used 7 of these at once, of these plugs, and out of the total of 8. And to me, it's a lot easier than having to have 7 AC adapters or transformers all plugged into a surge protector and daisy chained and all that stuff. This just seems to work better. And these cables can be made at any length I want. These are cheap ends from eBay, and then this is just speaker wire. And I'm fully aware this could have been done in a DC application, either modifying a DC power supply or just buying a DC power supply and then splitting the connectors out with a breakout cable or something like that. But I like this solution. It's pretty cheap and easy, and I'm using all the components inside each of these devices. They have an internal bridge rectifier, they have an internal voltage regulator and all that stuff, so why not put them to use and let them do their thing. So yeah, let's get this opened up and I can show you what it looks like inside, and we'll go from there. Okay, so let's quickly take this apart. Underneath, I've just got 2 Phillips head screws. And it comes apart just like that. And originally these binding posts and banana jacks up top here were just a 12 volt AC output. And now they're actually a pass-through, so I can use my multimeter to measure current. And if for some reason I didn't have my multimeter, I could always just use a jumper cable or even just a piece of wire between the binding posts to short those out, you know, so I could still be able to use it. And these, I believe I got from DigiKey, just because the ones on eBay didn't have as nice of a finish on them. We've got a switch that's on the 110 volt side and a 110 volt LED or light. Really, this probably should have been on the 12 volt side, but it is what it is. So inside I've got the transformer. This was from eBay. I believe I paid about $30 for it. I've got the fuse here, which is a 5 amp fuse. And then all these connections was actually just one wire that I snaked through. I use wire strippers and just cut kind of a circle around the cable in one spot and another spot, and then just cut it out with a knife. It just makes it a lot easier to make all these connections. Really, maybe it's not the best thing because this one wire is carrying all the current, and it's probably a little bit undersized for this. For me, it's fine for now. I'm going to see some current spikes, but I'm not really long-term trying to pull 5 amps all the time or anything like that. But in the future, I probably will update it a little bit with some bigger wire. And then on the input, I've just got a ATX power plug salvaged from a power supply. Just because I have tons of these plugs laying around and splitters and everything like that. So that's why I use that on the input side. All right, so now I've got a few things hooked up just to put a little bit of a load on there. And they are kind of real world applications like the pneumatic compressor instead of just unloaded motors. But let's go ahead and turn on our power. Let's get this turned on. Let's see, just that's a 1/4 of an amp. And again, this is on the input side on the 12 volts AC. Let's get the compressor going, let it build up pressure. And of course, as it builds up pressure, there's going to be more mechanical resistance, and it's going to increase the current usage of the power functions motors. So we're getting close to an amp already. Let's add that motor. And then if I use the servos, you can see we're already spiking up to about 1.6 amps. So it's pretty easy to put a somewhat substantial load on the system. So that's why I went ahead and updated from the 2000 milliamp transformer to something a little beefier, so this should do better. So I hope you've enjoyed the video, and if you have any questions or anything like that, you can drop them in the comments. So thanks for watching.